Hi, welcome back to LeetCode. Today I'm going to discuss LeetCode problem 1381. Design a stack with increment operation. So we all know about the stack data structure, right? So design a stack that supports increment operation on its element. So implement the custom stack class. First it will take the during the custom stack it will take the input as maximum size. It initiates an object of maximum size, which is the maximum number of elements in the stack. So it actually mention that what is the capacity of the stack, right? So another function is push. It will take x. So whatever the actually x value is, it will be stored into the stack. If it is if it has a capacity to store, right? Then it will store at the top. You all know about the stack properties, right? First, whenever we push anything new number, it will store at the top, and whenever we pop anything, this is the next function pop. It will pop from the top actually. So last in, first out, right? Last in, first out, LIFO. So in pop function will pop from the top, and it will return the top what is the value that we store in the top, and -1 if the stack is empty. That time we have to return -1. And another function is present extra. This is inc function. It will take two argument, one for k, another for value. So it actually may indicate that increment the bottom k elements of the stack of the stack by this value val. If there is less than k element in the stack, increment all the elements in the stack. Okay. So suppose for this example 1. So first of all, we are initializing a stack with capacity. What is the capacity? Is 3. Capacity is 3. Now we are calling push function with the value 1. So we are storing 1 here actually. Then we are actually again calling push with value 2. Now we have called actually pop, so it will be popped. So output will be 2 now, right? Now we are again call push. This will be actually popped. Now we are calling again push with value again 2. Okay. Now we are calling again push with value 3. Now again calling push with value 4. But what is the if can I store actually 4 here actually in the stack? No, because what is the capacity? Capacity is 3, and how many actually elements are already present in the stack? 3. So we have to reach the actually maximum limit. So we can't store 4 here, right? It will actually discard. We will not store. Now we are calling this increment function. What is the increment function? They will take two argument. One for k is equal to actually 5, and value is equal to 100. So bottom 5 element will be increased by 100, right? So here actually how many actually elements are present? 3. So all 3 will this is less than equal to k. So all elements will be increased by 100. So ultimately, what does the stacks look like? So this will be 101, this will be 102, this will be 103, right? Now again we are calling this increment function again. So what is the k value? K value is 2, and value is equal to again 100. So bottom 2 element will be increased by 100. So here actually how many elements are present? 3. So this actually more than actually k. So only 2 element, or the bottom 2 element will be increased by 100. So this will be increased by 100. This will be increased by 100. So ultimately, what does the stack look like? 201, 202, and 103, right? This is the stack current state of the stack. Now we are calling pop. So it will pop from the top. So output it will be 103. Now again we are calling pop. So it will already remove from the stack. Now again calling pop. So it will print actually 202. Now 202 also will be pop actually popped from the actually stack. Now if we call the pop function, then it will print actually 201, right? Now our stack is empty. Now again, if we suppose we call actually a pop, then what is it should actually print? It should print that time -1, because the stack is empty. That time we have to print -1. They mentioned that if we call the pop function and the stack size is actually empty, that time we have to return -1. Got it? Now we have to design this. Now how actually we can design this? We can actually implement this stack by using a vector. How? So whenever you get any capacity, first function custom stack, it will actually give us the capacity of the stack, right? We will store any variable, capacity variable, okay, and we will also initialize with the current index, like current index will be -1 because there are actually no element, or there is no element, so current element actually 0. Suppose current element is 0, okay, there is no element initially, and our capacity is 3, and we have taken a vector. Now vector is also empty. Now we see the function push. So what we will do, we will just push this into our vector 3. It will push into this, and current element will be adjusted to 1, right? Now again we call the push function with value 2, so it will store into the actual vector, and the current element will be 2. Now we call the pop function. So from the back side we actually just push, we will just actually pop that, okay, pop that, and it will be empty. Now our value will current element will be also 1 because I have already popped one element. Now our current element will be number of how many elements are present in the vector, only 1. Now we are again calling this push function. So what will trying to push again 2, okay, we have pushed back from the actual back. Now again we are calling the push function, we will store 3. Now the size will be for 2 will be for 2, and the size will be for 3 for the 3. Now we are again calling this push function with 4. Can I actually store 4 here, 4 in this vector? No, because we already reached the capacity, maximum capacity, so we can't store this. So this will be our vector look like after that also. Now we are calling this increment function. So increment function, what actually the input, k is equal to 5 and value is equal to 100. So what we'll do, we will check what is actually the bottom k element. So first k element will be increased. First k elements means 0 to k. 0 to k, this is the bottom k elements, right? Actually, if actually what is actually structure, 3 will at the bottom, 2 at the second last, and 3 at the top, right? This actually is actually the stack actually, but we will represent the vector. That's why this actually the from this to this actually the bottom to top, right? From left to right we are getting the bottom to top, right? So what I'll do, we will check what is the k value. K value is 5, and how many actually elements are present in the 3. So what is the minimum? Because that many times actually I can actually increase. So this is minimum actually 3. So first 3 elements will be actually increased by 100. So I'll just iterate this vector and I'll just modify this. So this will actually 103, this will be 102, and this will be 103 again. Got it? Now again we are calling this increment function with k is equal to 2 and value is equal to 100. Now this is our vector, and we're checking what is the k value 2 and how many elements are present, 3. So I can actually minimum value is 2, so I will increase only 2 elements from 0 to 2, 0 to 1, first 2 elements from left to right. So this will be increased by 100, so this will be 203, this will be 202, this will be 103, right? This actually our vector look like. Now we call the, if we call actually the pop function, then from this right to left actually I got the actually top to bottom. So if we call the pop, so it will actually return the 203, sorry 103, this is 103. Now again we call the pop, then it will return actually 202. Left to right, right to left actually we will iterate. Then if we again call the 203, again we call pop, then it will return 203. Again we call the pop, then it will return -1, right? It is clear? Now go to the code. If the logic is clear by using the vector, please like the video, and if you have any doubt you can actually comment that. Now what we are doing, currently we have actually C is actually represent how many actually elements are present. Limit is the maximum actually capacity of the stack, and this is the vector actually storing the actually elements in the stack. Actually in vector representative actually store using as a stack. Now here the this initialize function custom stack will get the maximum capacity. So we actually limit will be value will be maximum size, and current element will be 0 because there is no actually element present currently. Now we are actually calling the push function. What will get? We will get a x. So if our limit, if number of elements is present that is within our limit, we can actually first to check that we can actually store the current element not. How actually we can store? Check like how many actually elements are present in the vector, and the what is the capacity. So if the that mean number is less than equal to less than capacity, that time we can store. That time we will actually go into the if block and increase the number of elements. Like first time we are seeing, that time actually storing the 1 here actually. Okay, and count will be increased by 1. That's a count increased by C++. It will increase by 1, and C dot S dot pushback. This vector will be pushback 1. But now this is clear. Now it is a next function is pop. What to do? From right to left, actually I have to actually it will actually give us a top value, top of the stack. So that's why if our number of elements that present in the stack is greater than 0, that means what? There is actually at least one element. Stack is not empty. If C greater than 0 means C, what actually C indicates? C indicates that how many actually elements are present in the stack. So if C greater than 0, that means what? The stack is not empty. At least one element is present. So that time what will do? Whatever the last value is present in the stack, like vector, it will give, like here actually 1 is the last value. So S dot back will return actually 1, and I will pop back from this. So 1 will be removed from the actually stack. Got it? Now I'll also decrease this current minus C minus number of element present in the stack, because we are already popping one element. We have to adjust that, and after that return R. R means what? If there is no element, C suppose greater than is equal to 0, that time it indicates there is no element. So that time I have to return -1. So it will directly come here and return -1. Got it? And also if it is at least one element present, that time R will be modified here, and that it will return the modified value. Now one function is present in the extra in the custom stack. This is actually the increment. What actually it will take two value k and the value. So I will check how many actually element are present. S dot size, this will return actually the number of, also C actually when actually C also indicates the same thing, how many actually element are present in the stack, and the k. So I'll check what is the minimum value that will be increased, that number will be increased by a value. So that's I'm starting from I is equal to 0, I less than what is the minimum value, S dot size or the k, whatever the minimum. Like it can represent that we are trying to increase k is equal to 5, but only 3 elements are present in the stack, so all 3 will be increased. That's why we just check what is the minimum value, that will be increased by S dot I plus is equal to value. So all value I is equal to 0 to I less than that k, it will be increased by value. Got it? So it will store the modified value after increment operation, and whenever you calling the pop function after that, it will return the modified value because we have already modified that position. Right? Now we can actually what is the time complexity of this? So here actually constant time complexity, because we are just initializing the variable. Now it is also constant time big of 1, because we are just actually check, and if it is actually within the limit or the capacity I actually have, that we are just storing in the at the end. Pop similarly constant time big of 1, because we are just popping from the back, from the end, if there is any element. But for the increment function, you can check actually we are iterating from I is equal to 0 to I less than equal to k, I less than k. That actually big of k times. So this is actually not linear, but we can optimize this here. How actually? You can also observe that whenever we are calling this increment function, immediately we are not actually we do not need to immediately actually update the value. Why? Let's actually show the example. Now again, suppose we take two things. One of the actual stack, and this is the actually increment value. Okay, whatever the actually this increment function actually written. Now suppose this actually our stack actually look like 1 2 3. Okay, now we are calling k is equal to 5 and value is equal to 100. Okay, so ultimately okay, so now what I will store? I will store directly in this index. I will store as 100. Okay, now suppose we are calling push function again, push 4. So it will store 4 here actually, right? After increment operation. Now you are calling pop function. So what it should return? It should return 4. So 4 will be popped from the stack. Now again you are calling pop. So what it should return actually? 103, right? So what I will do actually, I will just during the pop I will just adjust this. How? This is the actual number and I will check what is the increment value. Okay, if there is actually any value, so I will just actually add that, add those two value. 100 plus 3, it will be 103. Now again we are calling pop. What it should return? 102. How actually adjust this? How can actually adjust this? So whenever popping this, so this element will be actually not present and this index will be invalid, right? So this will be also initial actually reset this. Now before resetting I actually propagate this to the actually before at the previous index. Why? Because stack operation only can do actually from the end or the top, right? So I actually done the pop. Whenever we go to pop, so I have this element will be actually element from the stack. So its effect will be go to the actually ultimately go to the next element, next top. So 2 will be in the current stock actually, current top. So that's why I will check whatever actually the value and that what is the actual value in the stack. So I'll just add this. So in this actually I will get the 102. Again actually this will be propagated to the before actually eliminate reset. I will propagate this value to the actually the next top. Okay. Now if I again call this pop function, it will return actually 101. Clear? Now it actually both are all actual elements. Now stack is actually empty. Now this is actually our increment value, increment array vector. You can actually now actually check that all value index value is actually now actually reset to the default value 0. No effect, no increment value actually present, and the stack is also empty. Got it? Suppose we again actually call the actually push function. Suppose 10, so it will store 10. Now we will actually call actually the pop. So what it should return? It will check what is the 10, what is the actual value stack in the stack 10, and what is the increment value 0. So 10 plus 0, it will return actually 10. Got it? So because you got it right, how to optimize this? The increment operation, we have just modified the last index. Whatever actually the index, it will be actually effect will be at the last effective index. So whenever doing the pop operation, that time we'll check if that index actually have any increment value. If that is present, that will be actually before reset that propagate to the next top element, right? So just go to the actually code actually. So you take actually two variable, one for stack, another for increment value. Usually store the actual value, and this is actually for the effective value or the increment value. And this is will store the capacity and the current index. So capacity is the maximum limit. So in the custom stack function, you can check actually we will resize these two vector stack and increment value with the maximum size, and all elements are initialized to 0. Increment value also initialized with 0. Now capacity is equal to maximum size and current index is -1. Current index -1 means there is no element. So this come to the push function. I will get in x. So when actually I can actually store this into the vector, into the stack, if it is a limit. So how can check current index, what are the current index I actually have, if that is actually less than equal to capacity -1. Right, suppose current index is -1 and capacity is 2 minus 1, so -1 less than equal to 1, so I can store this, right? So this will be stored. And suppose current index is equal to 0 and capacity actually 1 minus 1, so 0 less than 0, no, so we can't store new element because our current index is 0 means what? I have already stored one element and our capacity also 1, so that's why I have adjusted the 1 minus 1. But if it is if it is within the limit, so I will go to the actually this if block. I will just increase the pre-increment current index because it will be initialized to -1. So first it will go to 0. That 0 index it will store the x, right? So I am storing this stack vector, this stack actual value. Now I am calling this pop function. So if current index less than 0, that means what? Our stack is empty. That time return directly -1. And if there is any element that wanted to return whatever the actually last index and what is the actual value and the incremental value, both will be added that will be the actual value, right? If current index greater than 0, that means what? More than one element is present, more than one element. So if there is any effect of the increment value, that will be propagated to the actually next stop. So that's why I will adjust this increment value of current index -1, that will be added to the this current index, because we are popping this current index. So this effect will go to actually the previous index. So that's why increment value current index -1, that will be added to the this current index. Why am I adding this, not actually assigning this directly? Because there can be actually effect like suppose 1 to 2, so this is actually effective. Then again we are calling 1 to 3, so this will be actually the ultimate effect of the 1 to 3. So suppose this is 100 and this is 50. Okay, so the ultimately what value actually effective here actually effect will be 150, right? For this to similarly for this also 150, right? So that's why I am just adding this. If it is already there is an effect, that will be already present, but also for this index it will be actually added here. Now next in resolution, I will just reset this with 0 increment effect value. For the current index it will be 0 and the current index will be minus, because this index already actually popped out, and return the actual value. Got it? Now we will come to this increment function. This will here actually we got two argument k and value. If current index greater than 0, that means what? We have at least one element, current index greater than 0. So that time we can actually this effect will be work. So I'll check what is actually the rightmost actually the index. So I will get what is the minimum value, k -1. This will be the rightmost index from the k, and what is the rightmost index currently present. So what is the minimum, that will be actually the I can actually apply that rule, this effect. So what is the rightmost index, I will this increment value, I will actually increase that current value, that particular index limit id. Got it? So now what is time offset of this? Here actually work constant time big of 1, because we are just initializing this. Push also similarly even check, we are just constant time at the end, actually we are just inserting this, so it will take actually big of 1 time. Pop also similarly even check, actually we are just increasing the last index directly, so this will take actually big of 1. Here actually you can check actually that increment function will take actually big of 1. Why? Because we are just accessing that particular index limit id, we are not iterated, there is no for loop. But in the previous approach actually we have actually for loop, right? So here also optimize this big of 1. Understood, right? It is clear. I will share the code in the comment, and if any doubt, any suggestion, so you can actually comment on that also. And if you like the explanation, please like the video, and if you are not subscribed the channel, please subscribe the channel and share it with also friends here also. Thank you.